Up until this point, we've been looking at how to create relational database tables. In this lesson and the next, we'll be looking at how to retrieve and manipulate data in our databases. Now, in the previous lessons, whenever we wanted to perform any CRUD operations on our data, create, read, update, or delete, what we typically did was open up Visual Web Developer 2005 Express Edition. We got to the Database Explorer, navigated through, and until we found the table that we were looking for, right-clicked on it, and then selected something like Show the Table Data. And then we began to work with it in a very Excel spreadsheet type of format within the main area of our IDE. However, as we start to build our applications, there's really two ways that we will interact with data. And the first method is that we'll use ADO.NET's objects to retrieve, manipulate, and navigate through a table's rows and columns. And we'll highlight this in the last video in our series. But another method that we can use is actually the execution of special commands that are called SQL statements from within ADO.NET. We've already used the term SQL, or I think in one case I called it Transact SQL, several times up to this point in our lesson series. But what does that really mean? SQL stands for Structured Query Language, and it's a different kind of programming language in so much that it was created for a very specific purpose, and that is to allow you to retrieve, insert, update, and delete records from database tables. Now, SQL, or SQL as it's also pronounced, is a standard language across many different database vendors. However, Microsoft has added some functionality to standard SQL that provide a bunch of additional features that other database vendors can't or won't support. So sometimes when talking about the brand of SQL that Microsoft supports, you might hear the term T-SQL, or more commonly Transact SQL. But for our purposes, these are one and the same. So SQL is a very rich, robust programming language, giving you a lot of power and a tremendous number of options, but it doesn't look at all like Visual Basic or C#. Remember, it was created to solve a very specific problem, which is how to effectively retrieve data from relational database tables. So we're going to split up the topic matter into two videos. In this lesson, we're going to look at selecting data from a database, and in the next lesson, we'll focus on inserting, updating and deleting data using SQL statements. Now, for our examples, we're going to need to get you set up so that you can follow along. There are two resources that you're going to need. First of all, we're going to be performing ad hoc queries, and an ad hoc query allows us to interact with the database without having to create an entire application. We can execute one or more statements directly from within a special tool that allows us to compose statements, execute them, and then view the results. And the data that gets returned back to us is in a tabular style format, which we can then save to a text file or to a spreadsheet or just copy to the Windows clipboard. But this is different than consuming the data in a Windows Forms application or a Web Forms application. Now, in those applications, we might format the data nicely and allow some sort of interactivity with the data so our users can interact in a safe sort of way. But in ad hoc queries, the data comes back rather plainly. But that's exactly what we want. We just want to quickly perform some operation or review some database values without the overhead of creating an entire application just for that purpose. So to facilitate this, we're going to need to install a companion tool to SQL Server 2005 Express Edition called SQL Server Management Studio Express. So among some of the administration and data management capabilities that this tool will give us, we're also going to be able to perform some ad hoc queries, which is really what we want to do. So what we'll need to do if we don't already have it installed is open up a web browser and go to http://msdn.microsoft.com/express. And once we get to the Express home pages, we'll go to the overview for SQL Server Express from the little pop-up menu, the DHTML menu on the left-hand side. And then we'll need to scroll down just a little ways, and currently you can see that under Free Management Tool that we can download SQL Server Management Studio Express. This will begin the download process, and I'll let their documentation give you instructions on how to install this on your computer. But if you've ever installed any software, it's pretty straightforward. Now, once you have this software up and running, the next thing that we want to do is install the sample database that I created, and the download for the sample database should be in either a zip file or a .msi file, and located from the same place where you downloaded this video. So once you've downloaded it to your hard drive, if it's a zip file, then you'll need to open it up, and then what we'll want to do is copy these two files into a folder of your hard drive. So we're going to open up All Programs, Accessories, Windows Explorer, and navigate to our computer, C drive. Now this happens to be where I installed the SQL Server Management Studio Express. We're going to go to Microsoft SQL Server, MSSQL.1, MSSQL, data. Okay. You can see there's already some sample databases here, but we're going to copy our own two databases from here and drop them into here. Okay, so that's step one. Let's close all that down. Then we're going to open up SQL Server Management Studio Express. Whenever we get this dialog, we'll go ahead and select Connect. And then we are going to expand the Databases node and right-click on Databases and select Attach. This will allow us to attach to an existing database. Optionally, we can create a brand new database from scratch. This time we're going to select Attach. It brings open the Attach Databases dialog. We'll select the Add button. And then it will give us a file dialog that will allow us to select the name of our database. In this particular case, we want to select mycompany.mdf and then click OK. You can see the My Company database details are listed here. We find both the MDF and the LDF files. And unfortunately, this screen wasn't meant to run at 800 by 600, so I'm going to have to kind of move it around a little bit here, and hopefully I can get to the OK button at the bottom. Great. So now you can see it listed under my databases in the Summary tab, and also under databases within my Object Explorer. And as we open it up and take a look at our tables, we can see that we have 5 tables in our database. I created a diagram so that we can take a look at the relationship of these tables. Now, we're not going to talk about creating database diagrams in this series of videos. However, it's pretty easy to do, and it gives you an overview of all the relationships between our tables. Let's go ahead and size this a little bit smaller so we can see it all at one time. So we can see that we have, first of all, a customers table, and customers are related to orders. Each order can have one or more order items. Each order item is tied to a specific product, and each product is associated with a product type to qualify it. And this is, although a very simple table structure, it's very similar to other table structures that you're probably going to find or need to create for yourself. Now, there's nothing special about this. It's just a way for me to exercise the structure query language by selecting data from one or more tables. But I wanted you to be aware that there are 5 tables and that they are all related tables. If you're following along with me, I would recommend taking the time to go through each of the tables, right-clicking and selecting Open Table so that you can review the data that's contained within each of the tables and kind of look at the relationships. For example, how many orders would we expect, for example, Bill Brown, customer ID number 4, to have? Well, we can then go to our orders table and browse through all the customer IDs that are foreign key, have a foreign key relationship with the customer table. So here's one. You can see customer ID is 4. Here's another one, and so on. So I really encourage you to pause the video right here and take some time to review the database table structures. Okay, our goal here is to write ad hoc queries so that we can begin looking at some simple select statements to retrieve data from our database tables. So in order to facilitate this, we're going to select the New Query button on our toolbar. And this will give us a blank page within our main area that will allow us to write and execute our queries. So let's start with a very basic select statement. I'm just going to paste in our data here. Notice first of all that I have two little dashes. This means that this is a comment, a code comment. It appears in green, and this will not get executed whenever I choose to execute this query using the execute button or F5 on my keyboard. But as you can see, I have a simple select statement. Select star from customers. The star represents all of the columns. Let's go ahead and execute this query and take a look at what we get. Notice first of all that I get an error message, invalid object name customers. The reason this occurs is because I have not selected the database that I want to work with. Even though I may have it selected in the Object Explorer, we need to select which database we're querying from on the toolbar. So in this particular case, we're going to select my company, and now we're going to execute this query again. And this time you can see that we have in a tabular format the retrieval of all columns and all rows from our customer table. Now what if we don't want all of the data returned to us? Well, this is where we have a ton of options. For example, in this particular case, we're able to select just the first name column and the last name column from customers. Instead of just selecting the execute statement, I'm going to highlight the commands that I want to execute. So I'm going to put my mouse cursor over, hold down my left mouse button, and drag across the select statement, and then click the execute button. This will only execute the line that I have highlighted, which is a way for me to write a number of SQL statements, yet only execute the ones that I currently want to work with. As you can see, after I hit the execute button, I got the results first name and last name. I'm still retrieving all of the rows of data, but only 2 columns worth. Notice that the column names in the results are the same as what we have as the column names in the table. Now we may want to format this so that we can save this information off by selecting File, Save Result As, and then selecting either a .csv file, a comma-separated value file, or a text file. We may want to format these results a little bit differently. So in this particular case, let's paste in another statement. Let's go ahead and auto-hide this so we can see our complete statement here. You can see in this particular case, I'm going to alias the column name so that it's printed off a little more friendly. All I'm doing here is changing the column name as it is produced in the results from first name with no space, and here we'll just insert a friendly space to make it more readable. Again, we'll select our line and select execute, and you can see the only thing that changed was that the column names are different. Continuing on with this idea, let's go ahead and concatenate the content. Instead of having 2 separate columns worth of data, we're going to concatenate and format the values that are returned. So we'll take first name, whatever it is, in this case Jim, we'll add a space using 2 tick marks with an empty space in between, another string concatenation character, and then the last name column, and we'll call this new column customer name. Let's go ahead and select all of this and then click execute. Notice now we have a column called customer name, And all of our names now have the first space last name. Great. But say we want to limit the number of results that are returned back to us, that we don't want every record in the table returned. In that particular case, we can change our statement to include a where clause. Now we're going to be working with the products table, and so what we want to do is select a single record from our products table, and the condition that we want to satisfy is where the product ID equals 3. So let's go ahead and select that entire line and select execute. And now we can see that there's just one row returned to us where the product ID equals 3. And we can use a where clause within our select statement to define any number of conditions of the data that must be satisfied to return back to us the result set. For example, here's a slightly more complicated example. Here we're selecting every column from products where the product price is greater than 30. So as long as the product price column is greater than 30, we'll return those rows. You can see that in this particular case, all three of these rows satisfy that requirement. We can perform the opposite as well and only select those rows where the price is less than 30. And you can see at this point we're only selecting those items where the price is less than 30. We can use other operators as well, such as equals, or in this particular case, greater than or equal to $29.95. You can see that all of the items are either greater than or, in this case, equal to $29.95. And while we can use the equal sign, we can also check for inequality to make sure that we return any products where the product type ID is greater than or less than 2. So as long as it's not equal to 2, return those rows. So as you can see, as we move off to the right-hand side, we're only selecting those products with the type ID of 1 or 3, not 2. And not only does this work with numerical data, but it also works with character data. We can make sure to not select or any records where the product name is equal to inspired by widgets, or put another way, select all the products as long as the product name is not inspired by widgets. And you can see we are missing record number 4, which would indeed be the inspired by widgets row. To confirm this, I'm just going to copy and paste this and change the operator to equal. And you can see the opposite then would be to select only the row where the product name is equal to inspired by widgets. And not only does this work with numeric data and string data, but it also works with date data. In this particular case, we're making sure that from the orders table, we're only selecting those rows where the order date time is greater than 1/10/2006. Now you might say the fourth row that's returned is actually on 1/10/2006, but because we didn't specify a time, midnight is assumed. So that is why on the 10th, an order placed at 11:49 a.m. is still greater than midnight of 1/10/2006. Now I want to add one other feature as well, and that is to add a second condition using the AND statement. So we're going to check and make sure to only select those orders where the order date time is greater than 1/10/2006 and it's less than 1/13/2006. So that should eliminate potentially one row. Why? Because again, this assumes midnight, and we would expect to see order ID number 1 not included in this result set. But let's make sure by selecting and clicking execute, and indeed that particular row of data has been removed. Similar to the AND statement is the OR statement, which means that either the rows have to satisfy this condition or they have to satisfy this condition. The AND requires that both conditions be satisfied. The OR statement requires that either one has to be satisfied. Let's go ahead and select this. So if we read this correctly, we would expect to not see any records between midnight of 1/9/2006 and midnight of 1/12/2006. That period of time would not be included in our results. And if we scroll through, we'll see that indeed is the case. Now that some of our queries are getting a little longer, we can rewrite our queries in a more readable format, at least in my opinion. And that is to put each of the major pieces of our query on a separate line. So this line of code is equivalent to these lines of code. Let's move on and start talking about some functions that we can use within our applications, and these are analogous to functions that we might use in Visual Basic or C#, or some methods that are available there. For example, we can use the sum function to aggregate all of the values in the tax column from our orders table. So this would give us a report of all the tax that's been collected from our orders table. The count function gives us the total number of records within a given select clause. So in this particular case, let us know how many records are in the orders table. 17. We can also perform mathematical equations within our select statements. Now in this particular case, let me go and separate this on multiple lines here. We're going to select the product ID and then the product price, and we're going to alias this to a new name, regular price. And then we're going to create a second column, which is taking the product price and subtracting $5 from it, and we're going to call this the sale price. So notice that we're performing this equation in line. So we're going to go ahead and select these two lines and click execute. And notice that we get a regular price of $29.95 and $5 discount would be $24.95, all by just subtracting 5 from whatever values returned from the product price. Pretty cool. Similarly, we can give a 10% discount by multiplying product price times 0.9 as the sale price. Using the min function, we can find out what the least expensive item we have in our products table is. Or using the max function, we can find out what the most expensive item in our product table is. Or we can find out what the average price of all the items in our product table is. Not only are there functions to help us with math, but also there are functions that help us with dates. So in this particular case, we want to extract out the actual name of the month. If we were to, let's create this a little bit different. Let's do this as well. Well, actually, sorry here, I'm just doing this on the fly. So first we'll show the order ID, then we'll show the full order date time, and then we're just going to use the month function to tell me what the month number is, and the day function to tell me just what the day part of our date is. So you can see in the month column, it's all in January 1. And in the day column, it depends, 13th, the 12th, the 5th, the 7th, the 9th, and so on. We can use the getDate function, the getDate function to return the current date time, which is useful whenever we're doing comparisons between now and how many days it's been since a particular record has been in the database. And we'll show how that could be useful in just a moment. Here we can use a special function called dateName to retrieve a friendly date name instead of the numerical value. In this particular case, we want to select the month of the order date time from the orders table. You can see instead of returning 1, it returns us January. And I've listed just a quick help reference here that we can select just the year, just the day, the hour, or the minute, or the weekday, Sunday through Saturday. It's pretty neat. And this is similar to what we just did, except it, once again, the date part, as opposed to date name, returns us just the number, the numeric value. So in this case, 1, representing January. The dateDiff function will give us the difference between two dates. In this particular case, we're using that same little chart, this little nomenclature here to designate what are we comparing. In this particular case, we want to find out how many days separate today from the original order date time from each of the orders in the orders to tell us how old each of the orders are. So you can see that they really range, but they're within the 45 to 50 day difference. And just as we can perform mathematical equations within our select statements, we can also add days and subtract days, years or months or whatever, as specified by the particular date part. In this particular case, we're going to add 5 days to the order date time. Let's compare that to the original order date time. So you can see there is indeed a 5-day difference between this value and this value, for instance. And just as we can use functions to help us manipulate dates and math, we can also use it for strings as well. In this particular case, I am using the substring function in order to start at the 3rd character of my product description field within my database and retrieve the next 5 characters from that 3rd position. So we'll get some pretty funky looking results from this. As you can see, it doesn't make a whole lot of sense, but that indeed starts at the 3rd position and selects 5 characters. Similarly, you can use either the right function to select the rightmost 5 characters, or the left function to select just the leftmost characters, in this particular case 5. You can also make sure all the text is in uppercase or all in lowercase. And possibly my most favorite one is the reverse function, which, as I note, doesn't look to be very handy at first, but if you're a Cubs fan and like Harry Carey, I'm sure he could have made good use of this. Slightly more useful is the like clause. This allows us to search against a pattern. In this case, the pattern is that we want to find all first names that start with the letter J, and we use the percentage sign as a wildcard to indicate that any characters that come after that are just fine. So let's execute this. And as you can see, we have just those customers that have the first name that start with the letter J. Similar to the like clause is the in clause. By using the in clause, we don't have to string a bunch of or clauses together like select where state province equals IL or state province equals KS or state province equals PA or and so on. Instead, we can just make a list of those values that we want to satisfy with our where clause, and it'll only give us those in return. So let's go execute that. And as you can see, we've only returned those rows where the state province column equals IL, and you can see we have several rows that match that, or KS, and we have a couple that match that, or PA. Now let's take a look at how to order the results that we get returned back to us. And we can order the results by using the order by clause. So in this case, we will order all the customers by their last name. The ASC clause means that we'll order by ascending order. Let's go ahead and run this. So we can see it starts with BL, BR, BR, JO, and so on. Or we can perform essentially the exact same statement, this time changing to DESC, or rather descending order. So in this case, TAY, TAP, SU, ST, and so on. Or we can designate that we want to order first by last name and then secondly by first name. So in this particular case, if you'll take a look at the last name Smith, we have two Smiths, but we say we want to not only sort by the last name, but after we've sorted by last name, then sort by first name, and Angela comes before Jana. But the selects become a little more interesting whenever we can use some of the group by statements. So we've already looked at the sum, which allows us to get the total of a given column. But if we were to group those summations by another field, in this particular case the customer ID, we can determine what the total cost of shipping was each customer paid across all of their orders. And we can include one other piece of information in here as well. I think this will work. Now we can see how many orders this represents. In this particular case, customer ID number 3 had 3 orders for a total of $29.85 worth of shipping. Similarly, we can use the having statement to further reduce the number of rows that are returned. So this looks very similar to the previous example, but we've included one last statement, having count greater or equal to 3. So show me all of those customers who had 3 or more orders, and give me their customer ID and the amount that they paid for shipping. So only 3 customers had 3 or more orders, and this is the total that they paid for shipping across those 3 orders. Pretty cool. Okay, so now things are going to get a lot more interesting, because up to this point, I've only been selecting records from a single table. But what if you want to select data from 2 related tables using the relationship, the primary foreign key relationship between those tables? Well, to do that, we can use what are called joins. There's different types of joins. The only joins we're going to talk about in this series are inner joins. So as you can see, I'm going to select the product ID field from the products table, the product name from the products table, and the product type name from the product types table. So the product types in the products table are related. The from statement is going to provide some information to SQL on how these 2 tables are related and what SQL should attempt to join those fields on. So we're going to select from the products table, but we're going to make sure to inner join on the product types table. And the way we're going to do that is by setting the product type ID from the products table, the foreign key, equal to the product type ID, the primary key, in the product types table. So now let's see what we get here whenever we execute this two-line query. We get the product ID, the product name, and instead of a numeric value representing the product type, we're able to retrieve the full type name of the product: books, movies, music, and so on. Pretty cool. But wait, it gets better. We had to type out quite a bit of information. Every time we wanted to reference a given column, we had to predicate it with the table name. But we can shorten this using aliases. So select p.productID, p.productName, and pt.productTypeName from products, and here's where I create the alias p. So p represents products. Inner join product types, PT. So PT will stand for product types table, so we don't have to type the whole thing out. Inner join on p.productTypeID equals PT product type ID, and we'll get the exact same results. Now again, just with as we did in the previous examples where we were able to use all sorts of where clauses, you can do that with joins as well. In this particular case, we're adding a where clause to our previous statement. Here we're going to select all of the columns from the products table and the product type name from the product type table, but only return those records where the product price is greater than $29.95. And so that only returns 3 rows of data, but you can see here that we have both the product type ID and the product type name. And finally, you can create some pretty convoluted SQL statements by just continuing to use the same nomenclature of inner joins. So if we were to go back to our diagram, what if we wanted to find all of the products that a given customer has ordered? We'd have to go through the orders table, the order items table, and then finally to the products table in order to accomplish that. But we certainly can accomplish that because all of these tables are related. So for any given customer, we can find out all the products that they've ever ordered. The way that we would do that is through a number of inner joins. So we want, in this particular case, select the last name, the order ID, and the product name. Additionally, we're going to order the values that are returned by, first of all, by last name and then by order ID. So let's go ahead and run this monster query. So you can see the customer with the last name of Black has ordered in order ID 1 2 products, order ID 5 2 products, and order number 14 1 product. And you can see the product names for each of his purchases. Same thing with Briscoe, Brown, Johnson, LeBlanc, and so on. Very cool. Now honestly, all of these statements, all of the permutations that we just discussed here for the past few moments came off the top of my head. You get to the point working with SQL enough that it becomes second nature to you, just as Visual Basic, C#, whatever, will become second nature to you as well. So while this might seem a little overwhelming at first, once you spend a few days or weeks inside of a database, you'll begin to understand the lingo and be comfortable with how to get to the information you're trying to get to. But at first, admittedly, I had to buy books and read articles and really get to the point and really struggle with trying to get to the data that I needed. So I'd encourage you to take a look at the SQL help that's provided with SQL Server, and then maybe find a good reference book on SQL that will help you to work your way through and getting into the data that you need for your particular application. So that wraps it up for this particular lesson. In the next lesson, we're going to continue this thought, and we're going to move into some more advanced selects and insert, update, and delete syntax for the structured query language. And please visit www.learnvisualstudio.net and download over 500 screen cam video tutorials on many topics related to .NET, C#, Visual Basic, ASP.NET, and more. Thank you.